Imagine this for a moment. You're floating in deep space, completely alone. No planets, no stars nearby, just the quiet darkness of the universe. And then, in front of you, something strange appears. Not a glowing object, not a planet, but a perfectly dark circle in space, like a hole punched into reality itself. This is a black hole, and somehow, you're falling toward it. What would actually happen to you? Would you die instantly? Would you be crushed? Or would something even stranger happen? Let's follow the journey. Step by step. At first, nothing seems unusual. You're drifting closer to the black hole. Far away from it, gravity doesn't feel very different from any other massive object. Black holes don't suck things in like cosmic vacuum cleaners. In fact, if our sun suddenly became a black hole with the same mass, Earth would continue orbiting normally. Gravity at large distances behaves exactly the same. But as you slowly move closer, something starts to change. The black hole's gravity becomes stronger, much stronger. Stronger than anything we normally experience in the universe. This is because black holes pack enormous mass into an incredibly tiny space. For example, a black hole with the mass of our sun would be only about 6 kilometers wide. All the mass of a star, compressed into something the size of a city, and that extreme density bends space and time itself. This idea comes from general relativity, the theory developed by Albert Einstein. According to this theory, massive objects don't just pull on things. They warp the fabric of space-time. A black hole warps space-time so intensely that escape eventually becomes impossible. As you get closer, something very strange happens. Time itself begins to slow down. Not for you, but for the outside universe. If someone were watching you from a distant spaceship, they would notice your movements becoming slower, and slower, and slower. This effect is called gravitational time dilation. The stronger the gravity, the slower time flows. Near a black hole, gravity becomes so extreme that time almost stops compared to the rest of the universe. So to a distant observer, your fall would look like it's happening in slow motion. But for you, everything would feel normal. Your heartbeat, your thoughts, your movement, all perfectly normal. You would continue falling closer and closer to the darkness ahead. Now things start getting dangerous. As you approach the black hole, gravity doesn't pull evenly on your body. The part of you closer to the black hole feels much stronger gravity than the part farther away. If your feet are closer to the black hole than your head, your feet will be pulled downward much harder. This difference in gravitational pull is called tidal force, and near a black hole, tidal forces become unbelievably powerful. At first, you might only feel a slight stretching sensation, but as you fall deeper, the stretching becomes stronger. Your body begins to elongate. Your bones would struggle to hold together. Your organs would be pulled apart. Eventually, the force becomes so extreme that your entire body stretches into a long, thin stream of atoms. This dramatic process has a strange name. Scientists call it spaghettification, because you literally get stretched like spaghetti. Your body becomes longer and thinner as gravity tears you apart. For smaller black holes, this would happen before you even reach the event horizon. You would be destroyed long before crossing it. But for supermassive black holes, the story is different. Now you reach the most famous boundary in the universe, the event horizon. This is the invisible border surrounding every black hole. Cross this line, and escape becomes impossible. Not even light can escape. That's why black holes appear completely dark once something passes the event horizon. The laws of physics give it only one possible future: falling inward, forever. Here's the strange part. If you were falling into a supermassive black hole, you might not even notice when you cross the event horizon. There would be no wall, no sudden shock, no bright flash. You would simply drift across the boundary. From your perspective, nothing special happens. But to the outside universe, something incredible occurs. Now you are inside the event horizon. At this point, no signal you send can ever escape. The outside universe is permanently cut off. Even light cannot travel outward anymore. Space itself is flowing inward faster than the speed of light. Inside the black hole, The direction toward the center becomes unavoidable. It's like time itself is pushing you toward the core. No rocket, no technology, no possible force could stop your descent, and ahead of you lies the most mysterious place in physics: the singularity. At the center of the black hole lies a point where our understanding of physics completely breaks down. This is called the gravitational singularity. In theory, the singularity is a point where density becomes infinite, gravity becomes infinite, space and time collapse into something we don't yet understand. Every piece of matter that ever fell into the black hole ends up here, compressed into an unimaginably tiny region. But here's the problem. Our current theories cannot fully explain what happens at a singularity. General relativity predicts it. But quantum physics suggests reality might behave very differently at extremely small scales. Some scientists believe singularities might not actually exist. Others think they could lead to strange possibilities, like tunnels through space-time, or connections to other universes. Right now, no one knows for sure, because anything inside the event horizon can never send information back. The black hole hides its deepest secrets forever. So what ultimately happens to you? The truth is, we don't fully know. Your atoms would almost certainly be torn apart by extreme tidal forces. Your matter would be stretched, compressed, and pulled inward. Eventually, everything that made you, every atom in your body, would be absorbed into the singularity. Your mass would become part of the black hole, adding to its gravity, adding to its power. But your story wouldn't completely disappear, because black holes themselves slowly change over time. In the 1970s, physicist Stephen Hawking discovered something shocking. Black holes are not entirely black. They slowly emit radiation. This phenomenon is called Hawking radiation. Over incredibly long timescales, black holes can slowly lose mass. Eventually, after trillions or even quadrillions of years, they may completely evaporate, which raises a profound question. What happens to the information of everything that fell inside? That mystery is known as the black hole information paradox, and scientists are still trying to solve it. So what would happen if you fell into a black hole? First, gravity would slowly pull you closer. Then time would begin to behave strangely. Next, tidal forces would stretch you like cosmic spaghetti. Eventually, you would cross the event horizon, the point of no return, to the outside universe. You would appear frozen at the edge, your light fading into darkness. But for you, the fall would continue, deeper and deeper, into the most mysterious place in the universe, a region where space and time collapse, where physics breaks down, and where the true nature of reality may be hiding. A black hole is not just a cosmic object. It's one of the greatest mysteries humanity has ever discovered. And somewhere in the universe right now, millions of them are silently waiting. If you enjoyed this video, make sure to like the video, share it with your friends, and subscribe to the channel for more cosmic mysteries. And let me know in the comments what topic you want to explore next.